2, 1.
Hi, I'm John Doolittle. This is Patrick Dackins and Steve Masino, and our project is the Smart Stove. So the layout of what it does is it'll detect smoke up in here, and that'll send a signal starting a timer. And what the timer will do is it'll set off after 15 seconds. We'll close this solenoid valve to the gas, and this gas here will shut off. After that happens, the timer will still be counting, and behind we have a CO2 filled canister or cylinder, and it's charged, and then this valve will open, extinguishing the fire.
Sweet. All right, we're gonna do a demo?
Yeah, so let's start it up.
Demo. So our fire's cooking. Oh geez.
So we should hear the smoke alarm. That's the smoke alarm. So the timer is now started.
Okay.
And we should see the flame go off on the stove.
Solenoid valve is just closed. You can
Solenoid
see the
valve.
gas. Cool. Gas shut off. Excellent.
Might want to take a step back.
Yeah.
A little bit for the seat.
That's real.
Fire is out.
Yes. Very good. Very good.
Now Patrick and Steve will go into the circuit a little bit.
Okay, so one of the first circuits that we designed was the, we actually used a transistor because we were worried about the smoke detector being not a consistent signal as far as how many volts it would put out and how the Arduino would read that. So we actually use the transistor, PNP transistor, as a switch. So we used the 5-volt pin from the Arduino and ran that through the transistor. So it was always getting 5 volts. And then when the smoke detector goes off, anything above 5 volts will actually put the transistor in cutoff. So that shuts off the flow of the 5 volts. So we had to write the code in reverse logic so that it understood when the smoke detect was actually occurring, and then that would start the timer. And then that would actually allow the valve to close once the timer reached that given time.
So how did you create all those timers?
So we use states and flags to create the timer. So we initially had to start out with all our flags being at 0, and then as a certain sequence happened, we would change the state to 1 and 2, or just to 1, and then from there we could base everything else off of it.
Cool.
Some of the other things we had to use an H bridge for our operation of our solenoid valve, because it is a mechanical ball valve inside there.
On the gas line right here, this one.
Nice.
And we also have a reset button, so by pressing the reset button, it reverses it and can reopen it. We also had to use a 12-volt regulator because we have 2 9-volt batteries in the back to operate the solenoid valve.
Yeah. So what are some, what would you say some of the challenges, the highest challenges you guys faced?
I think the highest challenges we faced was the initial writing of the code, getting started with the flags and stuff like that.
Yeah, reverse logic was a little tricky.
But just getting that initial ball rolling and jumping in there.
Jumping in there's probably the most difficult part of trying to get the project started.
And our valve on the CO2 line kept freezing. It would freeze up.
Oh!
So we didn't want to lose all our CO2.
Okay.
We had to manually shut that off. So we set our timer for a less amount of time. So
Yeah.
And we definitely need to give a shout out to Mr. Hitchcock,
And
Mr.
Grover.
Levan, and
Mr.
Grover as well,
And Dr.
providing us with the valves and giving us help on building the entire thing. And definitely, of course, Mr. Cheng Su with the code writing and the electronics portion. He helped me a lot with the that transistor part that I talked about as
Oh,
well.
and who donated the CO2?
Oh, we have Vallejo Fire and Extinguisher Company.
Yeah, filled the bottle for us.
Filled the bottle.
Great.
They're definitely awesome.
So advice to, you know, this is an awesome project. Everything is laid out nicely. Like you got the standoffs, the printed circuit boards, clean, painted, it's beautiful.
Yeah.
It really, really works.
It works.
Advice for the incoming class for next year.
get started sooner.
Yeah.
Get started early.
Yeah. So even though you don't have as much time with all the labs, is get your project down and start. And Dr. Chang Su and Dr. Clapstein, they're always there to help. So you can just go in anytime to get help with the code and
Yeah,
everything.
definitely don't be scared to ask for help.
Yeah.
Don't, wait on it. Just take advantage of all the help that's out there. Also, I would say pick something that is cool to you, something you're interested in, because then you are going to put a lot of time into this, so it's good, you're going to want to like it.
Cool. Doolittle, anything else on that?
Definitely, I thought what Pat did was get the parts early, because without the
Yeah.
CO2 valve and the other valves, we wouldn't have had a project. So the
That's a
parts,
good point.
getting those early to make sure that we had them, that was big.
Oh, one other thing as well that Dr. Chang Su helped us realize is you want to write a little bit of code and then test it, write a little bit, test it. Like he said, serial print is your friend. Don't try and write the whole code and then test everything at once, because it'll be much more difficult to figure out where the bug is, where it's going wrong.
Cool. All right. John,
Thank you.
thank you. Mr.
Thank you for all your
Dackins,
help.
thank
Thank
you.
you.
Masino, thank you. Fantastic project. Very proud of you guys. Full stars. Excellent.
Thank you very much.